How can a function remember a variable after the code that created it has already finished running? That's not a trick question, it's real, and by the end of this video you'll watch it happen live. Start simple. I take a function called greet, put it in a totally different variable, and it still runs exactly the same. Because in Python a function isn't special. It's just a value, like a number or a string. Hey, I'm Kai. Welcome to Fun with Learning Technology, the channel where we don't just run code, we figure out why it don't just run code. We figure out why it works at work after the code. You've already passed a function into another function without noticing, sorted names, key equals len, hands the len function itself into sorted. That's it. That's the whole trick. Functions as arguments. Decorators just do that automatically on every function every time it's called. That's where we are headed. Here's the setup. I define one function inside another and the inner one reaches out and uses a variable from the outer one. Normally, once outer finishes, its variable should be gone. But watch what happens when we call the inner function later. I used to think this was basically magic. Honestly, it took me longer than I'd like to admit to realize what was going on. Python notices the inner function still needs that variable, so it keeps it alive instead of throwing it away. That link between the inner function and its enclosing scope is what we call a closure. Let's make it concrete. MakeCounter returns a small function that adds 1 to a hidden count every time you call it. Run it twice and watch the number climb. That count never resets, because the closure is holding on to it between calls. Say you want to time 10 different functions, or log every call. Copy pasting the same lines into each one works, but it's exactly the kind of repetition that should bother you. My honest opinion, that repeated boilerplate is a bigger maintenance risk than people give it credit for. We need one wrapper that adds that behavior to any function without touching the function itself. Here's the trick. A decorator is just a function that takes another function as input, defines a new function around it, and returns that new function instead. Nothing mysterious. It's the closure pattern we just built, used on purpose. Putting the @ symbol and a decorator name above a function looks like new syntax, but it's not doing anything special. It's exactly the same as calling the decorator on the function yourself and saving the result back under the same name. Let's run it for real. I wrap a slow function with a timer decorator, call it exactly like normal, and it prints out how long it took. No changes to how I call the function. Here's a question for you. What do you think happens if I print out the wrap function's own name afterward? Drop your guess in the comments before the next slide, then I'll show you. Turns out, the wrap function forgets who it is. Ask for its name and you get wrapper, not the function you actually wrote, and its documentation disappears too. That's a real problem the moment you're debugging or using tools that rely on function names. The fix is one line. Add functools.wraps above your wrapper function, pointing at the original, and it copies the name and documentation across automatically. Now the wrapped function looks and behaves like the real thing again. Clean. So here's the whole picture. Functions are just values, which means you can pass them around. A closure is a function that remembers variables from the scope it was created in, even after that scope is gone. A decorator uses exactly that trick to wrap extra behavior around a function without touching its code. And functools.wraps make sure the wrapped function still looks like itself. That took me a decade to learn. Takes you a second to learn, takes you a second to like and subscribe. If something feels off or missing, or you want to see something new, tell me in the comments.